Hello folks, we are back with yet another video of this exercise 7.1. Here we have just learned how to apply the integration formula, and we are applying the integration formula. Every time that we are applying the formula, we are taking care that we are writing the plus c, only then the antiderivative part will be taken care of. So that's the thing to begin with. We had a small list of functions and the integration that will to start with, and as I said, as every exercise proceeds we will add to our list. More and more formulae will keep coming, and that's how we will be learning through the entire concept. So in the last exercise last video we had finished the 12th problem. Now it's the 13th problem which is there on the board. We're supposed to do this now. All this time we had the 12th and 11th problem where we had only the monomial in the denominator, so we were like kind of distributing and we were doing the problem. But now here it's the binomial which is there, or rather it's x minus 1 which is there, so we are not able to use that idea. So we'll go towards the idea of factorization, and maybe that will help us. So let's try to factorize the numerator. If we carefully observe, we can factorize, of course, we can factorize this, and it will have x minus 1 as a factor. If you can take these two terms, there is x squared common. So x squared times x minus 1. Here 1 times x minus 1. Denominator x minus 1. So overall you have the x minus 1 common. And then there is this x squared plus 1. So because the x minus 1 is common, you can have that cut. So we are left with x squared plus 1. Let's get the integral. Integral of x squared dx plus integral of 1 dx. Integral of x squared, it is x cube over 3, and integral of dx, we know it's x plus c. So it's very easy once we reach here, but then that will come only by observation and things like that, whether factorization is working or not. You have to do the factorization, or you can resort to long division, and with the help of that you can work out this and get the problem. So it's a problem number 13. So let's now move to the problem number 14. See what it says. Problem number 14, it says that you have integral of 1 minus x, again integral of 1 minus x times root x dx. I'll check for the thing. Yeah. So what we do is we open up the bracket. So when we open up the bracket, the first one is root x when we open up, and the second one is x root x dx. Let's try to look at the exponent part. This is x raised to half dx, and this is x raised to 1 plus half. So that's how it is. X raised to 1 times x raised to half. So 1 plus half, 1.5, which is 3 over 2. So this is x raised to half, and this is x raised to 3 over 2. When we take the integral, this will be x raised to half plus 1 over half plus 1, and this is x raised to 3 over 2 plus 1 over 3 over 2 plus 1 plus c. So that's x raised to 3 over 2. X raised to 3 over 2. 3 over 2 here. So that will become 2 over 3. And here it's 5 over 2. And 5 over 2, which will become 2 over 5. Yeah, so that's about it. So that helps us to get that problem done. Now we can move to the 15th problem. Let's see what it says. It says, again, it's almost like this problem. So it says that I equal to, we have I equal to integral of root x times, you have a polynomial, 3x squared plus 2x plus 3. As we did here, now we'll expand it and then we'll work with it. So it is going to be 3x squared root x dx, first term. Next, 2x root x dx. Next term, 3 root x dx. So let's look at the exponent. This is 3 x raised to 2 plus half. Check that. So also this will be x raised to 1 plus half, and this will be x raised to half. So this is going to be 2 and 2 for 5 over 2. 3 times x raised to 5 over 2. This is going to be x raised to 3 over 2. And this, as we know, is x raised to half. So when we get the exponent, we know it's going to be 5 over 2 plus 1 over 5 over 2. So this is going to be 7 over 2. You can calculate. And 2 over 7. So also this is going to be 5 over 2. 3 over 2 plus 1 over 3 over 2. So 2 over 5. Then half plus 1, which is 3 over 2. So 2 over 3 when we write the reciprocal. So we'll get 6 over 7 x raised to 7 over 2, 4 over 5 x raised to 5 over 2, 2 times x raised to 3 over 2 plus c. This is our problem number 15. 14 and 15 very identical. That's for our problem number 15. This should be all for this video. With some more problems, let's meet in the next video. Thank you.